Hello everyone, I'm Amodini. I'm a CSE student at IIIT Sri City. PYQs of circular motion. Okay, so let's just hop on to the questions. The first question is, a particle of mass 10 gram moves along a circle of radius 6.4 centimeter with a constant tangential acceleration. What is the magnitude of this acceleration if the kinetic energy of the particle becomes equal to 8 into 10 to the power minus 4 joule by the end of the second revolution after the beginning of the motion? Okay, so here, like we know, the concept is again circular. And we have been given the mass, and that is in grams. I've told it so many times in my previous sessions also that you have to focus on the units given because there will be times when the options are very similar, right? Okay. And then we have the radius, and then we have we've been given that the tangential acceleration is constant, okay? So what is the magnitude of the acceleration if the kinetic energy becomes equal to this? So kinetic energy, they are equating it to 8 into 10 to the power minus 4 joule. Okay. Okay. So how do we solve this? First of all, we'll convert, right? It's important to convert it into kg. So 10 by 1000, and you'll get it. And then the radius, it's in centimeter. Okay. Kinetic energy, it's been given as this. So tangential acceleration is what we have to calculate. We know that kinetic energy is basically half mv square, right? And that is equal to E. And similarly, we have been given that it is 8 into 10 to the power of minus 4 joule, right? So from here, I can calculate it, right? Cross multiply it. We have the mass, that is 10 by 1000 into V square is equal to 8 into 10 to the power minus 4. So substituting the values and then calculating it, we get it as V is equal to 4 into 10 to the power minus 1 power minus 1 meter per second. Now, what we have to find is the acceleration. We just don't need the velocity. So for that, we'll use the laws of motion, right? Direct formula, V square is equal to U square plus 2AS, right? And here, A is the tangential acceleration, okay? Not the centripetal one. So substituting the values, you'll get it here. One thing again, this was in centimeters. So we'll be converting it into meter and then using it. And why is it 4 pi r? Because we know that one revolution, it is 2 pi r, because the distance is the circumference. And they have told that by the end of the 2 revolutions, you have this value. So therefore, that means that we'll have multiply it into 2 and then do it, right? Make sense? Okay, let's move on to the next question. So with this, you get it as 0.1 meter per second square. And that is our option A. Okay. Moving on to the next question. It states that two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speed VA and VB respectively. Their time period of rotation is the same. The ratio of angular speed of A to that of B will be what? Okay. So what do you mean by concentric circles? So this is what you mean by concentric circles, okay? So these are concentric circles. And what they are telling is, this is RA. Let's make this RB. And this is RA, okay? Yeah. So we have been given PB are same, okay? So I'll equate it to T, okay? And then we have been given RA, RB, and then VA and VB. So what we will write it as, we have to find out omega A and omega T, right? So how do we do that? Simple formula. We know that omega A is equal to 2 pi by TA, right? Similarly, omega B will be equal to 2 pi by TB, right? So TA and TB are equal. So directly you can say that it is 1:1. Okay, pretty easy, right? Yeah, here you can see this is the same. Finally, you'll get this, right? Okay, moving on to the next question. A mass m moves in a circle on a smooth horizontal plane with a velocity v0 at a radius r0. The mass is attached to a string which passes through a smooth hole in the plane as shown. Okay. The tension in the string is increased gradually and finally m moves in a circle of radius r0 by 2. The final value of the kinetic energy is what is the question. So here there is energy concept and there is circular motion a little. Again, we'll be using angular momentum also over here, okay? So what they are telling is that they basically, there was a body mass, okay, that was moving in a circle. But then what happens is the tension is increased and then that particle which was moving in the r0 circle, it'll start moving in r0 by 2. Okay, so how do we do this? So what we'll do is, we know that the angular momentum, not the normal momentum, but the angular momentum. Angular momentum will be conserved. Yes. So therefore, L initial should be equal to L final. So initially it was M V naught R naught. And then finally it is M V dash. We don't know the we don't know the velocity yet. So R naught by 2. Okay. So with this, M gets cancelled, R naught R naught, and then you get it as V dash is equal to 2 V naught. Okay. So you got this. Now you just have to directly write it into the K final. So here you can see that K final will be equal to half MV dash square. This is not comma, this is multiply. So with this, you'll just substitute as 2V naught square. So you'll get it as, so 4 into half MV naught square, and that will be equal to 2 MV naught square. Okay, cool enough? Okay, moving on to the next question. So the next question is, a particle starting from rest moves in a circle of radius r dash. It attains a velocity of v0 meter per second in the nth round. Its angular acceleration will be. Okay, so this is a direct Newton's law of motion question. Okay, so it's a direct one. So what we'll do is, we'll just directly write it as v square is equal to u square plus 2as. We know that. Finally, it is v naught square, okay? Because it's been told that it attains a velocity of v naught meter per second in the nth round, right? So it'll be v naught, it'll be v naught square. That is equal to, initially it's starting from rest, so it'll be 0 over here, and then it'll be over here. There are a few things that we'll have to keep in mind. So first of all, acceleration is basically angular acceleration we need to calculate. So what I'll write it as 2. I know that A is equal to R alpha, yes, and this is the angular acceleration. So I'll substitute it over here, 2R alpha into 2 pi r because it's the circumference, that's the distance, right? Into n because there are n rounds that are being taken, right? And with this, just take, you'll get it as v naught square by 4 pi n r square. So that is our option D. Here you can see how close the options are. At times we might just pick the option A because there is an R and then there's an R square. So we need to check the options pretty clearly, okay? So yeah, let's move on to the next question. The next question states that Kepler's third law states that square of period of revolution of a planet around the sun is proportional to third power of average distance r between the sun and planet. That is, t square is equal to kr cube. Here k is constant. If the masses of the sun and planet are m and m, I think this is supposed to be small m. Okay, let's make this small m, right? M and m respectively, then as per Newton's law of gravitational force of attraction between them is F is equal to gm m. Here g is the gravitational constant. The relation between g and k is described as what? Okay, so here it is more of forces being involved, gravity and Kepler's law. And we know that t square is directly proportional to r cube. That is what the Kepler's law states, right? And here they have equated it with a constant. And we need to find out the relation between K and this G. Okay. So how do we do that? First of all, we know that the gravitational force of attraction is equal to the centripetal force, right? Here we can, yeah. So we can equate it and then you'll get it as, we'll get our velocity over here. Okay. So basically, I equated my gravitational force with the centripetal force. Okay. So because, let's say there's an object over here. Here, there will be gravity. There'll be a force of attraction, okay? And then similarly, because of the rotation and revolution, there will be centripetal force also. So therefore, we are equating it. And then the time period of the planet. Time period of the planet, we can write it as 2 pi r by v, right? So substituting the value of v over here, you'll get this equation. So from Kepler's law, we've learned it as t square is equal to kr cube, right? Capital R. So substituting this over here, you'll finally get this as your answer. So the solution would be option B. Okay. Moving on to the next question. Two racing cars of masses m1 and m2 are moving in circles of radii r1 and r2 respectively. Their speeds are such that each makes a complete circle in the same time t. The ratio of the angular speeds of the first to the second car is what? Okay, so here it is the direct question, right? They have given us m1 and m2, and then there is r1 and r2. But what do we need to find? We just need to find the angular speeds. And we know that angular speed is nothing but 2 pi by t. And they have taken the same time. So therefore, what will happen? You'll have omega 1, omega 2, and both will be 2 pi by t itself. So you'll get the answer as 1:1. Okay? Yeah. Moving on to the next question. two racing cars of masses m and 4m are moving in circles of radii r and 2r respectively. If their speeds are such that each makes a complete circle in the same time, then the ratio of the angular speeds, again, this is the same thing. We know that the angular speed just depends on the time, right? So therefore, they have told that this time is same and pi is a constant and 2 is also a constant. So therefore, it is again 1:1. It was a direct question. Okay, moving on to the next question. So it states that one of the end of string length L is connected to a particle of mass m, and the other end is connected to a small peg on a smooth horizontal table. If the particle moves in a circle with speed v, the net force on the particle directed towards the center will be, where T represents the tension in the string. So here we'll be covering the concepts of tension and string and the net force. Okay. So first of all, net force on the particle of on a particle in uniform circular motion is basically the centripetal force, and that is always mv square by L. Okay, it's a uniform circular motion, right? This and let's just say this is the body, and this here is a string, right? Okay, this is the string. So here there is centripetal force mv square by L. So this centripetal force is provided by what? That should be an external thing, right? And that is provided by the tension in the string T. So if the particle moves in circle with speed v, the net force on the particle will be what? So it will be directly T. Okay? And no, it will not be T plus mv square by L. That is wrong. This is wrong. Because here we are talking about the net force of a uniform circular motion. And in a circular motion, there has to be an exterior initiation. Okay. So therefore, the option is D. Okay. On to the next question. A mass M is attached to a thin wire and whirled in a vertical circle. The wire is most likely to break when the mass is at the lowest point, inclined at an angle of 60 degrees from vertical. The mass is at the highest point. The wire is horizontal. Okay. So we had this similar question before, right? So here, and let's just say here. So when we are over here, there is tension, and when we are over here, there is theta, and there is over here it'll be mg, and I'll take this over here, so it'll be again theta, so mg cos theta, and this will be mg sine theta. But over here, theta is equal to 0. Therefore, it is most likely to break when tension at the lowest point is maximum. Okay. Here, there is complete tension because here there is complete mg acting over here. When there is, it's at this point, or let's just say this point, or even this point, what happens is there is a part of mg acting on it. there is a theta because of which the net force is C less, right? So therefore, what you will do is we'll consider the lowest point, and then you see that T will be equal to mg. And this is the point where the string might break. So the option is A. Yes? Okay. Moving on to the next question. Okay. A uniform circular disk of radius 50 centimeter at rest is free to turn about an axis which is perpendicular to its plane and passes through its center. It is subjected to a torque which produces a constant angular acceleration of 2 radian per second square. Its net acceleration is in meter per second square at the end of 2 seconds. Okay. So basically, we need to find the net acceleration at the end of 2 seconds. So how do we do that? Firstly, conversions needed. That is 50 centimeters. So that is 50 by 100 meters, right? Okay. So first of all, angular acceleration is equal to 2.0 radian per second square. And time is equal to 2 seconds. We know that. So I can tell that my tangential acceleration is equal to r alpha, and that is 0.5 into 2, that is equal to 1 meter per second square. Okay. So yeah, it's over here. And then angular speed. Here again, we are applying Newton's law of motion. Okay. So applying that, you will get omega to be equal to 4 radian per second. Okay. And then we'll calculate the centripetal acceleration, and that is equal to omega square r. So substituting the values, you'll get 8 meter per second square. Okay. But then the linear acceleration is a, we calculated it over here, that is a tangential, that is equal to 1 meter per second square. So what we'll do is we need to calculate a total, right? Yeah. So why would we do this AT square plus AC square? Because this A total is actually a vector, right? So we have AC vector plus AT vector, and we know we'll do it by vector addition. And why is there no cos theta involved? That's because AT and AC are in this direction, 90 degree. So basically, if there is a body moving in a circular motion, let's say over here, A tangential is in this direction, and then A centripetal is towards the center. So we have to calculate this acceleration, and that is A total. So with that, you'll get approximately 8 meter per second square, okay? And that will be our option A. Because they have told approximately, we need to tell it, right? Okay. Yeah. So the next question is, a mass m moves in a circle on a smooth horizontal plane with velocity v0 at a radius r0. The mass is attached to string which passes through a smooth hole in the plane as shown. Okay. The tension in the string is increased gradually, and okay, this is the similar question that we did. Again, we'll be just applying the conservation of angular momentum. Conservation of angular momentum. Okay, so that will be m v naught r naught is equal to m v dash r naught by 2. So this gets cancelled. This and this gets cancelled, and you get it as v dash is equal to 2 v naught, right? So therefore, final kinetic energy will be half m 2 v naught whole square. So that will be 4, and then it'll get cancelled. So you'll get it as 2m v naught square. So that is our option B. Yeah. Moving on to the next question. The next question states that a particle of mass 10 gram moves along a circle of radius 6.4 centimeter with a constant tangential acceleration. What is the magnitude of this acceleration if the kinetic energy of the particle becomes equal to 8 into 10 to the power minus 4 joule? So again, we will directly write this as half mv squared is equal to E. Okay, again, substitute the value. Half into mass is 10 by 1000 to v square is equal to 8 into 10 to the power minus 4. So therefore, you'll get v is equal to 4 into 10 to the power minus 1. Similarly, we'll apply the Newton's law of motion over here and then calculate the value. And finally, you'll get the tangential acceleration should be to be 0.1 meter per second square. So that is our option A. Okay, so moving on to the next question. A body initially at rest sliding along a frictionless track from a height h as shown in the figure. This completes a vertical circle of diameter AB is equal to D. Okay, the height h is equal to what? So they have given that track is frictionless. So what do we know if it is given frictionless? That means there is no loss of energy. Therefore, we can apply the energy conservation, mechanical energy conservation. So we'll write it as total mechanical energy initial should be equal to total mechanical energy final. Right? So initially it is 0 plus mgh, that is equal to half mv square L plus 0. Why is it 0? Because initially it is at rest, right? And then finally it reaches the ground over here. So the height would be equal to 0, right? This is VL, okay? So with this, you'll get h is equal to v square L by 2g, okay? We know that for completing the vertical circle, okay, we know that VL must be greater than root of 5g r, right? So that means h should be equal to 5g r by 2g. Yes? And why did I get this? So here you basically got h is equal to v square L by 2g, right? So I'll just substitute the values over here. So v square L is 2gh. So basically I can write it as root 2gh is equal to root 5gr. So cancel the roots. So you'll be left with, and cancel the g also. H is equal to 5r by 2. And r is the radius. And we've been given diameter. Since it's the diameter, it will be 5 by 4d. And that will be our answer. So, and that is option D. Okay, moving on to the next question. Two particles A and B are moving in a uniform circular motion in concentric circles of radii RA and RB with speed VA and VB respectively. Their time period of rotation is the same. The ratio of angular speed of A to that of B will be. So basically omega A we have, and then we have omega B, right? And we know that it depends on 2 pi by t. Similarly, 2 pi by tb. And we know that TA and TB are equal. So therefore, it will be 1:1, and that is option B. Yeah. Moving on to the next question. So an electron moving in a circular n, okay, n per seconds, okay. The magnetic field produced at the center has magnitude. Okay, so this is mix of circular motion and magnetism. So what they are telling is there is an electron moving in a circular orbit, sorry. So this is the electron, the circular orbit, and the radius is r, right? So we know that I is equal to Q by T. Here I is the current and Q is the charge. And charge of an electron is E. So I is equal to E by T, right? And T will be, yeah. So what I can write is T is nothing but 2 pi by omega. Yes or no? T is nothing but time period, right? We've just learned omega is equal to 2 pi by T. So I can take this over here and then bring this over here. So you'll get it as omega is equal to, yeah, you will get it as T is equal to 2 pi by omega, right? And therefore I'll write it as I is equal to E by 2 pi by omega. And then I can still write it as omega E by 2 pi. But we've been given that it has made n rotations. So revolutions. So that will make us 2 pi n e by 2 pi. So you'll get cancelled it and you'll get I is equal to ne. And we know that magnetic field is equal to B is equal to mu naught I by 2r for the center, okay? This is the formula for the center. So we have I substituted as Ne. So you get it as mu naught Ne by 2r. And that is option D. Okay. So moving on to the next question. The radius of the circle, the period of revolution, initial position, and sense of revolution are indicated in the figure. Okay. Y projection of the radius vector of rotating particle P is? Okay, so basically, here we've been given that radius is equal to 3 meter, and then period of revolution is equal to 4 seconds, and initial position was over here. So this was my initial position. T is equal to 4 seconds, right? T is equal to 4 seconds, and this is the initial position, and the sense of revolution is in this direction, right? So how do we approach this question? We need to find out the y projection of the radius vector. So the y projection is what we need to find. So what we'll do is, firstly, y is equal to r cos theta, right? So I can write it as r is basically over here 3, and we have cos theta. But how do we still find theta? Theta is nothing but omega t, right? So I'll write this as 3 cos of omega t. But then we know t, but we do not know omega. So what? But we also know that omega is equal to 2 pi by t. So I'll write it as 3 cos 2 pi by t. And t is basically this. Okay, yeah. Don't confuse it with this t and the time period. This is the time, okay? And this is the time period. So these are two different things. And here I'll write it as 2 pi by t into t. So I can still write this as 3 cos 2 pi by 4 into t. So I'll write it as 3 cos 2 pi by 2. So it will be pi by t, pi by 2 into t, right? So this is what you get. So therefore, it will be y of t is equal to 3 cos pi t by 2, where y is in meter. Okay, so today there were a lot of concepts that we learned. So let's quickly revise the concepts that we learned. So firstly, we have covered angular acceleration, angular velocity. So in most of the questions, what we did was we approached it using the Newton's law of motion. And no, Newton's law of motion is applicable to the circular motion too. Okay, so we covered this, and then we had a few tension questions wherein the string was whirled, right? The string was whirled, and then we had to calculate. Yeah, and then we had to calculate the velocity or tangential acceleration or any such thing. So that was one of the question. And there were questions wherein we used conservation of angular momentum. So over there, what we did was we just equated the final and initial. So this is initial, let's just say, and we equated it with the final angular momentum, and then we would calculate the missing term basically. And then there were also questions wherein we conserved the total mechanical energy. And how do we decide if we have to focus on total mechanical energy or angular momentum? If they say there is a frictionless plane, or they say there is no resistance, then that means there is no energy loss. Okay, so that is the implication that we need to capture, and then we have to use total mechanical energy conservation, or else most of the times we are just going to use, yeah, most of the time we're just going to use conservation of angular momentum. Okay, and then there was one question wherein we had to calculate the total acceleration. That was one of the new questions that we hadn't came across yet. So right, so over there, the different thing was that in a circle there was centripetal acceleration, and then there was tangential acceleration. So we had to calculate the resultant acceleration, which was over here, acting over here, right? So A total is equal to root of AC square plus AT square. Okay, so this is what we used, and this was pretty new. And this is nothing complex because it is just scalars and vectors concept that we just completed it in the previous session, wherein we learned it's the resultant sum. Okay. And then another unique question that we came across was the ones wherein we had to calculate angular speed, wherein they would give us mass, velocity, radius, time period, and everything. We need to remember one thing, that our angular speed or angular velocity does not depend on any of these. It depends only on our time period. So the time period is basically t by 2 pi omega. And similarly, it's vice versa. Okay. So with this, we must remember that they might give us like many other quantities too, which are invalid. So rather than wasting your time, check if the time periods are different or they are the same. And then calculate the angular speed accordingly. Okay. Moving on, we also learned a few questions wherein we had to equate the centripetal acceleration and the tension. So there was one question wherein we learned that our centripetal acceleration is actually produced by one of the factor and not something wherein you add it as t is plus mv square by l. It is something that it gets produced due to the tension. So therefore, the net value would be always equivalent to the ones that has been given. That is nothing but the tension in our previous case that we had. So with this, I would like to conclude this session. So make sure that you guys learn whatever I've taught you guys. So when it comes to solving these questions, don't stick to just one of these questions. These are few of the PYQs that you would have learned, and you will have to come across like various such questions. This is mostly like 2015, 2016 questions. So what you could do is you could search for similar questions and then have or work on such topics wherein you are weak. So telling this, I'll be wrapping up this session. Thank you so much.